Is it visible? Okay. So, can you read anyone? Can you, can anyone, can anyone read? Still on joining. Okay, all of you carefully listen. Try to join as early as possible within 5 minutes for next coming classes. Is it clear? Okay, are you seeing the screen? See the next topic. Anyone read? Okay, all of you see the PPT. The next topic is classification of DC motors. Okay, already we have studied about the DC machines. Okay, construction wise it will be the same for motor and the generator. See here we are going to see the classification of DC motors. First point, based on the type of construction and electrical connection, a DC motor can be categorized into four major types. Okay, what are the four major types? See here we can see a brief chart based on type of construction and electrical connection. Here we can see two things. One is construction, second one is the electrical connection. What is the type of construction and the electrical connection? Based upon these two, so the DC motors are divided into different types. See here types of DC motors. We know that, so it is classified or divided into three types: separately excited, second one self excited, third one permanent magnet. So we know that the separately excited, it is the single only. In the self excited DC motor can be divided into three types. Okay, first one is the shunt excited DC motor, series excited DC motor, compound excited DC motor. So this compound excited DC motor again divided into two types, that is cumulative compound, differential compound. isn't it? These two again, so divide into long shunt and the short shunt. We can say that long shunt cumulative compound DC motor, short shunt cumulative compound DC motor. In the same way, long shunt differential compound DC motor, short shunt differential compound DC motor. So these are the different types of DC motors. We can see what are the applications of DC motors. So in today's industrial sector, so that means in industries, in what way, so these motors will be utilized. See here, so today's industrial sector, direct current motors are everywhere. So these DC motors, that is the direct current motors. We can say that. So in blindly we can say DC motors are utilized for doing heavy works. Doing heavy works, these motors have been utilized. So you can see. So in today's industrial sector, direct current motors are everywhere. So from robotics to automobiles. So from robotics means small motors. So you can see in robotics. So for having so different applications, they are using the small motors. So we can consider small motors. DC motors have been utilized in the robotics, and so from to automobiles, big automobiles, we can see in big industries. So they are using the big motors, so DC motors. So that means from robotics to automobiles, everywhere, so we are using the DC motors. See here, small and medium sized motoring applications often featured DC motors for their wide range of functionality. So nowadays, so earlier days, for doing heavy works, so they are using the DC motors. So nowadays, so moreover all applications have been so utilized. Is it clear? Okay, is there Naveen? Just now joined. Naveen, respond. Okay, I will see in the next class. So all of you, once again I'm telling you, so within 5 minutes you have to join. So we are giving, so for every period break is 10 minutes. Okay, that is more than enough. So to take breath, so you can join. Again we are giving 10 minutes time means 20 minutes. So there is no time for class. Earlier we have 1 hour. That is plenty of time. Nowadays only, so from today onwards, we have 50 minutes per one period, so that you can adjust. So try to understand. So within a 5 minutes, you have to add in the class. Have you understood? So here, so we can keep it on mind. So these DC motors have been utilized from robotics to automobiles. From robotics means small motors to so big application. Automobiles means industries, big industries. They are using the big size of DC motors. You can recognize what is the importance of DC motors nowadays. See here, because DC motors are deployed in such a wide variety of applications, and there are different types of DC motors suited to different tasks across the industrial sector. So that means we have to know the importance of the DC motors. Is it clear? So we will see one by one so about the DC motors. See here, the main types of DC motors. Understanding the different types of DC motors will also help to understand how they are used for different applications and which type of may apply to your application. So here, so we are trying to tell, so what are the different types of motors, so corresponding to the construction and so type of connection. If you understand, then easily you can recognize or you can understand, so for what application you can use suitable motor or the DC motors. So if you know one by one, so then you can understand, so where we have to use it. So without knowing connection and purpose, you should not say for what application you can use suitable DC motors. See here, we can see, all of you see types of DC motors. See here, a direct current motor. So what is direct current? That is the DC motor. So DC is named according to the connection of the field winding with the armature. We have discussed in the DC generators also how the field winding is being connected to the armature. So for different types of motors, here also based upon the field winding connection, in what way we have to be connected the field winding, so with the armature. So we can say the different types of motors. See here, mainly there are two types of DC motors. What are they? So one is separately excited DC motor and other is self excited DC motor. So it is similar to DC generators. We have discussed so DC generators. See here, the self excited motors are further classified as shunt wound or shunt motor. We can say simply shunt motor or shunt wound DC motor. So next one, series wound, or simply we can say series motor, and compound wound or compound motor. Is it clear? So we have discussed different types of motors. So that is so in self excited basically classified into so series motor, shunt motor and the compound motor in your syllabus. So in your syllabus we have only shunt motor and the series motor. So we have the separately excited DC motor, in self excited only two, that is shunt wound and the series wound. In the same case of DC generators also. Have you understood? See here, the DC motor converts electrical power into mechanical power. So what the DC motor works, how it will be working, isn't it? So what is the job of DC motor? We have to understand. See here, so the DC motor, what it will do? The DC motor converts electrical power into mechanical power. So motor means here DC motor. So if you taken the DC motor, construction wise it will be the same. So DC machine or the, so either you can use generator or the motor. Construction wise it will be the same. So in what way we have to utilize? See here, what is the input of the DC motor? That is electrical power. So what is the electrical power? DC power. So we are giving the DC power is the input power to the DC motor. So what is the output? So we are getting the mechanical power. See here, the DC motor converts electrical power into mechanical power. So the construction of the DC motor and generator are the same. So we know that the construction wise it will be the same. So we have seen all the parts of DC machine. DC machine. So what is meant by machine? Machine may be a generator or the motor. In what way we have to be utilized? Suppose you want to be used, so that DC machine as a generator. So you have to give the input is the mechanical, output you will get it electrical. Suppose that same DC machine you have to be used as a motor. So you want to used as a motor. So what you have to do? You have to give the electrical supply is the input, output is the mechanical. Have you understood? See here, the construction of the DC motor and generator are the same. So we know that. So the DC machine is nothing but so either motor or the generator. So the DC machine so will be the same. So construction wise it will be the same, both generator and the motor. See here, so but the DC motor has a wide range of speed and good speed regulation in electric traction. See, if you observe in electric traction, so anyone tell me what is meant by electric traction? Electric traction is nothing but so we are using in trains, isn't it? So electric trains. In electric trains, so can you tell me either which supply we are using in electric traction, either AC or DC? Very good. DC supply. So that we can see only single line. Okay, so only single wire. So that we are using. So that is also very high tension line, isn't it? Okay, so they are using the DC. See here. So in DC motor, so it is used for more speed. So this DC motor having capability so to give more speed and to handle the large work. Is it clear? So that's why only it pulled out so heavy trains. So we know that so how many bogies carrying of one single engine. So if you see in a goods train, so more than so 50 bogies, but in general train so maybe so 15 to 20 bogies, isn't it? So our compartments we can say that. See here, so but the DC motor has a wide range of speed and good speed regulation in electric traction. So that's why only so especially in so traction purpose, so we are using the DC series motors. Okay, the working principle of DC motor is based on the principle that the current carrying conductor is placed in the magnetic field and a mechanical force is experienced by it, isn't it? Here, what will happen? So, in DC motor, so what we are doing in a DC motor, see here the current carrying conductor. So, where we have to place current carrying conductor? So, what is the meaning of current carrying conductor? So, if you taken a DC motor, isn't it? So, DC motor means what is the input? So, we are giving the DC current. Okay, so our DC power supply we are giving. So, the DC current is flowing through the armature. Is it clear? So, see here the current carrying conductor is placed in magnetic field. So what we are doing, the current carrying conductor is placed in magnetic field. So what will happen? A mechanical force is experienced by it. Suppose so we are taking a current carrying conductor, isn't it? So that current carrying conductor you have to place in magnetic field. So what you can observe, isn't it? A mechanical force is experienced by it, isn't it? So if we are using the armature, isn't it? So that armature is placed so in the magnetic field. So what will happen? So mechanical force experienced by it. So what is the mechanical force experienced by it means? It will be rotating. So it will be rotating in clockwise direction. Is it clear? So that means, or you can say that. So the current carrying conductor also you can test it. The current carrying conductor is placed in magnetic field. So you can see the vibration or mechanical force is experienced by it. So in the conductor it will be moving. Have you understood? Okay, that is the meaning of that. The DC motor is generally used in the location that requires a protective enclosure, for example drip proof, the fire proof, etc. So according to the requirements, the detailed description of the various types of motor is given below. So we can see what are the different types. So that means according to purpose, so you have to use so different types of motors, isn't it? So suppose for cranes, so for lifts, is escalators, or traction purpose, we are using the series motor. Okay, like that for applications, different applications, we have to use suitable DC motor. So we can see in our syllabus we have separately excited DC motor. In self excited DC motor we have shunt wound and the series wound. In our syllabus only three: separately excited, shunt and series. So there is no compound wound motor in our syllabus. Okay, we will see the construction and detailed explanation. So first we will see separately excited DC motor. Okay, so what is meant by motor? So you can see the diagram. So what is the current direction? So from the load, isn't it? So we are giving the current, isn't it? So here, so wherever be the load, so we have to take the, isn't it? So you can imagine, so these are the socket, isn't it? So in our house so we can see the socket voltage is directly available, so you can plug it in. So that wires you have to be put it. So this current is passing through armature. See here, so we are giving the supply to the armature. So first one is separately excited DC motor. All of you see the diagram. So what is meant by separately excited DC motor? The field winding is being separated from the armature. So we have to be taken separate field winding. So which is given by the DC supply, and so field current is flowing through the, so this is the field. So that is separately excited field. See here armature. So we can see the armature. So it will be connected to the terminals, isn't it? So we are taking the current. So that is the armature current is entering to the armature. Whatever be the current is flowing through the armature, so that is the armature current. So what is current? That is equivalent to the line current. So whatever be the line current, same current is flowing through the armature. See here, so this is the construction of separately excited DC motor. So it is very similar to the separately excited DC generator. We have studied DC generator, separately excited DC generator. See here, as the name signifies, the field coils or field windings are energized by a separate DC source, as shown in circuit diagram shown below. So we can see, so this is the separate DC source, so for energizing the field. So this total setup, so we can call it as separately excited DC generator. So DC motor, not generator, DC motor. So we can see self-excited DC motor. So the self-excited DC motor, we know that these again further divided into three types: series wound, shunt wound and the compound wound. So see here, as the name implies, self-excited. Hence in this type of motor, the current in the windings is supplied by the machine or motor itself. So here what we are doing, so the current in the windings is supplied by the machine or motor itself. So earlier, so you can see the difference, generator and the motor. So for the motor direct, so input is the electrical. So electrical power we are giving, that is the DC power we are giving to the motor. See here, self-excited DC motor is further divided into shunt wound and series wound motor. So they are explained below in detail. So why? So we have shunt and the series wound motor in your syllabus. So that's why we will see these two only. So compound wound also you know that. So we will see the applications. So first we will see one by one. Shunt wound motor. See the diagram, shunt wound. You know that. So all of you see the diagram. So it is very important, directions. So in the earlier case generator, so we can see the directions. So from the armature only we can see the direction, upward direction, isn't it? So that current only will be splitting, isn't it? So but here in motor means, so from input, so you have to observe the input. What is the input? That is the terminal voltage. So you can see, so terminal voltage across the load, so that is the input. So that only we are giving. So here directions are very important. So if you don't know, so you may confuse, isn't it? So difference between the motor and the generator, isn't it? So in the generator the input is the mechanical, in motor input is the electrical, isn't it? So see the arrow mark. So we can see shunt wound motor. Shunt wound motor, how to draw the shunt wound motor, or in another way, so how the field winding is being connected. See here the field winding, so we can say that shunt field winding is being connected in parallel with the armature or shunt. So in parallel with the armature or the shunt as shown in figure. So this entire setup we are giving to the, so terminal voltage or the load, so capital V. So see here the line current, see here this line current or the load current actually. So in generator you have to spell out, so that is load current. So in motor, so you can say that line current only. So what you can call line current. In motors IL is the line current, in generator IL is the load current. Have you understood? So see here in motor the line current is divided into two, or splitting into armature current and shunt field current. Armature current and the shunt field current. So if you know, so how to draw this diagram, so remaining thing it is very easy to understand. So coming to point, shunt wound motor. So this is the most common type of DC motor. Here the field winding is connected in parallel with the armature as shown in below. So we know that here, so the field winding is being connected in parallel or shunt with the armature. Okay, it is called the shunt wound motor. See here the current, comma, voltage and power equations for shunt motor are written as follows. We will see how to write the equations for current, voltage and power. So current is I, voltage is V, power is capital P. So these equations we have to develop in shunt wound motor. See here we know that, so applying KCL, Kirchhoff's current law at junction A. So here whatever be the dot, red dot, so that is the junction A in the figure. See here the sum of incoming currents equal to sum of outgoing currents. You know the KCL, isn't it? So at this point what is the entering, that is the line current actually. So capital I is the line current, which is equal to IA plus ISH. What is IA? So that is the armature current. ISH, what is the shunt field current. So where capital I is the, so input line current, IA is armature current, ISH is shunt field current. You know that according to the diagram. So if you see the diagram, you can write the equation 1, isn't it? So then equation 1 is the current equation. So what is the equation 1? So we have developed, so according to the diagram, so what is the total current or the line current is equal to IA plus ISH, that is the, so current equation. So next we will see voltage equation. The voltage equations are written by Kirchhoff's voltage law. So what is meant by Kirchhoff's voltage law, isn't it? So you know that algebraic sum of the voltage drops in a closed loop is equal to 0. See here Kirchhoff's voltage law for the field winding circuit. So for the field winding, so we can see, so what is the field winding? So we have taken shunt field winding, that is RSH, isn't it? So here V equal to, we know that, so according to Ohm's law V equal to IR. So here what is the I? So that is whatever be the current flowing through the RSH. So that is ISH RSH. So what is the voltage? Okay, that is the voltage at the shunt field winding V equal to ISH RSH. That is give the equation number 2. So next one, armature. Coming to the armature, for armature winding circuit, the equation will be given as. So what will be the, so capital V. So here, so capital V. So you can see the diagram. So what is the capital V? So this is the load. Okay. So capital V equal to E plus IARA. In case of generator, isn't it? So what is the terminal voltage? V equal to EG. So EG minus drop. So here, so this total input only, so it will be separated. Okay, whatever be the power, we are giving the power. So what is the power? Electrical power. So what type of power? DC electrical power, isn't it? So that we are giving to the motor. So here, so whatever be the generated EMF, that is the back EMF we are calling. So back EMF plus drops. Okay, whatever be the drops, that is equal to, so supply power, isn't it? So that point you have to know. So this is very very important point. If you not understand this, okay, so you couldn't able to understand the machine diagram. So this is voltage V equal to ISH RSH, that is the second equation. So it is very very important. It's a capital E. So capital V equal to E plus IARA. Or in another way we can say that in the motor, so the terminal voltage V equal to, so that is the E is the back EMF, E plus IARA, or generated EMF plus IARA drop. Okay, this is the equation 3. The power equation is given as, see here, power input. So we are giving the, so DC input power, that is equal to mechanical power developed. So whatever be the power, the mechanical power developed plus losses in armature. So whatever be the losses we have to consider plus losses in the field. So these two losses, armature losses and the field losses. Have you understood? So here the input power, this power will be divided into 3. So mechanical power, then some of the armature losses, some of the field losses, isn't it? So this is about the input power. So we can develop the equation 4. So what is the VI? That is the DC power we are giving. So how much power we are giving to the motor? So that is the DC power. So VI, isn't it? So here, so see that, so what is the mechanical power developed? So that we are assuming capital P suffix M. So that is mechanical power. So plus losses. So what are the losses in armature? That is the armature losses, I square R losses. Is it clear? So that is IA square RA. Plus what are the other losses? In field winding, shunt field winding. So that is the I square R losses in shunt field winding. So ISH square into RSH. So this is the equation 4. How did you get equation 4? So from this, okay. So input power, so that will be, so it will be developed in the motor. So how we are giving, so we are giving the, so input DC power. So that output power actually we have to get it the mechanical power. So what is meant by motor? So motor is convert electrical power into mechanical power, isn't it? So actually, so mechanical power plus some losses also will be occurred. So what are the losses in this case? So in shunt field winding you have to consider armature losses plus shunt field winding losses. See here, so corresponding to that we can develop the equation 4. So this is the electrical power equal to mechanical power plus armature losses plus shunt field winding losses. See here, so VI equal to, so P suffix M plus I square RA into RA plus this you can write it V equal to IR. Okay, so that is V equal to ISH RSH. So we can see the diagram. So in this V equal to ISH RSH. Is it clear? So see the equation number 2. So see the equation number 2. So we will get it. So substitute here V into ISH, isn't it? So this ISH square RSH, I can write it V into ISH. What is the V? V is nothing but ISH RSH. So from equation 2. From equation 2. So next you can write it. So this from this you can separate the mechanical power. So what is the mechanical power? Equal to VI minus what is the remaining? V into ISH minus IA square RA. So from this you can take it common V. So V into I plus I minus ISH, I minus ISH minus IA square RA. Is it clear? So see here I minus ISH. So from the equation 1, I minus ISH, you can write it IA. IA equal to I minus ISH. From equation 1 you can substitute here, that is IA. So I minus ISH, what is the value? IA. If you substitute you can get it. So PM so equal to VIA. IA is nothing but I minus ISH minus IA square RA. So from this you can get it the common IA. You can get it out. So V minus IA RA into IA, isn't it? So here, so this you can write it mechanical power equal to, so V minus IA RA. So V minus IA RA. So from the equation 3 you can see V minus IA RA, what is that? Capital E. So I can write it. So capital E equal to V minus IA RA. So if you substitute there, so capital E minus IA, isn't it? So what is the equation 5 gives mechanical power equal to, so generated EMF into armature current, isn't it? So what is the generated EMF? That is the voltage in the armature and armature current is. So this mechanical power, this electrical power is being converted in armature. What is that? E into IA. Have you understood? So see the equation multiplying equation 3. All of you see the equation number 3. V equal to E plus IA RA. So what you have to do? So multiply equation 3 by IA. So if you multiply with IA for equation 3, you will get it equation 6. So V into IA equal to E into IA plus IA square RA. Have you understood? So see the equation 3. So if you substitute you will get it, sixth equation. So then, so I can write it equation 6. So V into IA as it is. So E into IA. So see the equation 5. So I can substitute this. So P suffix M. So E into IA is nothing but the mechanical power. P suffix M plus IA square RA. So this is the equation number 7, isn't it? So what is the so power? So that is V into IA. So that is the voltage into armature current. So that is the power in the motor. So will be converted. So that is the mechanical power plus IA square RA, isn't it? So this is corresponding to the armature. So in the armature, so we are giving the DC electrical power. So that will be converted to mechanical power P suffix M plus losses, isn't it? So where V into IA is the electrical power supplied to the armature motor. Have you understood? This is about the shunt motor. So voltage, current and the power equations. So you have to practice. Is it clear? Okay, so I will continue in the next class. I will take the attendance.